Hi guys, this is today's lesson on congruent triangle proofs. We're going to continue the work we started last time. I'm just going to work through them, talk about what I'm doing, and hopefully this helps you understand how to solve them. So remember with proofs here, we label what they give us and we're trying to build two congruent triangles. That's pretty much always our first goal. So here they tell us that angle JAM is congruent to angle IMA. JAM is congruent to IMA. They tell us JE is congruent to IE, and AE is congruent to EM. So that's all given to us. We do not have to write about that. That's all technically in my dash there. All right, so what triangles can we build? If I look at this, I'm looking for triangles that have the most parts. They gave us plenty of pieces here. But if I were like to trace this side, right? Trace that side, trace this side. Those are two pieces that they gave us. We have two pieces of this blue triangle. And I know that's kind of hard to see, but this is the stuff you're going to have to be on the lookout for. So we have two pieces of these blue triangles. So I'm going to kind of draw it off to the side just so that we can, let's see here. So if I copy and paste that. So here's my triangle, right? What are the parts that we know? We know that we have this side with a match. We have this side with a match. That's it. This entire corner is not used, right? We have just this part, but we don't have the individual pieces. So we look at the picture. What do we see? And we should really be looking for shared sides, right? The worksheet's called overlapping parts. Do the blue triangles overlap anywhere? No, but they do have vertical angles. So I'm going to call them angles 1 and 2. So in my proof, I do have to write about that. Angle 1 is congruent to angle 2. Those are vertical angles. So that's this guy right here. Do I now have enough to build that triangle? Yeah, that's all we had to get. We now have side, included angle. Two sides and the included angle. We can say that triangle JEA is congruent to triangle IEM. And that is two sides and the included angle. If you can do that much, if you can get me two congruent triangles, I'm going to give you more than half the points. The rest of it can be pretty tough. So let's take a look at what we have to do next. They're asking us to prove triangle J, that's not a great color, triangle JAM, and that it goes with triangle IMA. So I know it can be kind of hard to tell what to do. So we're looking for two things. Like, guys, it's like a to-do list. Like if you're sitting here stuck, you're asking yourself, do these triangles overlap with each other? Do these triangles overlap with the triangles that we just built? Those are the questions we're asking ourselves. So first, do brown and red overlap with each other? Well, think about what those names are called. JAMIMA. AM. They have two letters in common in the name. So they both use AM. Look in the picture. They both use this side. So like if I kind of redraw this brown triangle, there's a shared side here. We also already have this corner. This corner was from the given. So that shared side, we can say AM is congruent to AM. And that is reflexive. Okay, we still need something else. So they overlap with each other, right? Brown and red both use the side AM. Does red and blue overlap? Do they have anything in common? Look at my red and blue, JAM, JEA. What do they both have? They both have JA. Look in the picture. Don't they both use this side, JA? Yes, they do. So based off the name, what do we know? We know that JA is congruent to IM. So the whole reason we built those blue triangles was so that we could use their parts in the next triangle. So we now know that JA is congruent to IM. and that is CPCTC. We have congruent parts of congruent triangles. 1, 2, 3, 4 matches 1, 2, 3, 4. Right? Brown and blue overlap over here. Red and blue overlap on the left. Those are congruent parts because of the two blue triangles. We can now say triangle JAM is congruent to triangle IMA. And that would be two sides in the included angle. That's SAS again. Ba, 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 I'm a jam, I'm a jam. There we go. Let's go. We got this, guys. You can do this. Where did they overlap with each other? Where do they overlap with the previous triangles? Okay, next one. V is the midpoint of ZX. I'm going to mark it. I'm going to write about it. A lot of you forgot to write about this on your quiz. So VZ is congruent to VX. And that is just we're going to say just definition of midpoint. Not definition of bisector, right? They didn't say V is a bisector. They said V is a midpoint. Same premise, but they said midpoint. So we say midpoint. Then they tell us that these angles these lines are perpendicular. Well, that means actually all four of these corners are 90 degrees. And I told you we're going to cheat a little bit. So I'm going to call this angle 1 and 2. We have two options, by the way. So let's look at this real quick. If I were to draw this red line, how many triangles use it? 2. I could turn left and make the left side. I could turn right and make the right side. It doesn't matter. We could do either way. We're going to use the right side, though. So I'm going to go this direction. And so I need angles 1 and 2. So I'm going to say angle 1 is congruent to angle 2. And I'm just going to say perpendicular lines lead to congruent angles. You can just say definition of perpendicular, even though it's not technically correct. But I'm letting you cheat a little bit. But basically, perpendicular lines make 90-degree angles. 90-degree angles are going to be congruent. So we're cheating a little bit, but that's okay. We get the idea. Okay, so if I trace that angle, like you can already kind of tell, if I trace the corner, I'm only one line away from making this red triangle, and it has a friend down here. So you're always on the lookout. What triangles do they give me the pieces for? And they gave me the pieces for these red triangles. So if I kind of draw it over here, what pieces do I have? I have the left side. I have this angle. So I need something else. So we're looking, do they overlap with each other? Do they overlap? Well, that's really just each other because we don't have any other triangles right now. And the answer is yes. They both use VY. VY is congruent to VY. That is a reflexive piece. They both use it. We can now say, we got this side now, so we can now say that triangle ZVY is congruent to triangle XVY. And that is side angle side. So we just got over half the points on the test if you can just get me two congruent triangles. So now's the tough part. The next thing they're asking us to do is to prove triangle ZUY is congruent to XUY. This won't be easy, guys. So maybe take a pause, see if you can think about how it would work. In class, I had the students try to do it without my help. So see if you can do it. But I'm going to work it out right now. So pause it, see if you can do it, and then check out the rest here. So what do we have? We're looking for two things. Remember your to-do list. Where do they overlap with each other? Purple with purple. Where do they overlap with the previous triangle? Purple with red. So if I draw the purple out, right now I have nothing. But they both use the side UY. So they have a shared side. UY is congruent to UY. That is a reflexive piece. They both use it. All right, so now I got a shared side. That's it. That's the only place they share sides with each other. But how about purple with red? And you can even tell by the names. ZUY, ZVY, ZY, ZY. They both use Z and they both use Y. That means that the side ZY is in both of them. Look, ZY. So there's my next thing. So we're going to say ZY is congruent to XY. How did we know that? ZY, XY. That is from those triangles, that CPCTC. All right, this next thing, this is really tough. There's no more overlapping sides, but red and purple, they touched. Remember we were talking about Z and Y? Let's talk about this. So it takes 2 letters to make a side. It only takes 1 letter to make an angle. But just because it's the same letter does not mean it's the same angle. What do I mean by that? How many angles use the letter Z? 1, 2, 3. Ooh, it makes a little smiley face. 3 angles use the letter Z. So just because they both have the letter Z doesn't mean it's the same letter Z. The purple Z is the whole thing. But look, the red Z is just that part. So they don't both have the same angle Z. What about Y? Do they have the same letter Y? Well, there's 3 Ys, right? The big one and the 2 small ones. And yes, look, purple and red both use this angle. I'm going to call it angle 3, and this one angle 4. Red and purple, like, guys, if this was like a 20-degree angle, wouldn't the purple triangle have a 20-degree angle? Wouldn't the red triangle have a 20-degree angle? They both use the letter Y, and it's the same letter Y. So I'm going to say angle 3 is congruent to angle 4, and that is also CPCTC. That is the Y and the Y from the name. They're the same letter Y. Are you feeling good about that? All right. All right. Oh, I'm actually misspoke a smidgen. It's this Y and this Y. Those are the same Y. This Y and this Y are actually different Ys, but they're the same size. One of them's this Y, one of them's this one, and they are the same size. Sorry, I misspoke a smidgen. So we now have this and this. So can we now say the end goal, which is triangle ZUY, is congruent to triangle XUY, and that would be side, angle, side. And we got our proof. Okay, let's keep going. Triangle PRT. Sorry, angle PRT. Angle QST. We got RT and ST. And then we've got RU and US. Okay, alrighty. First step, first thing on the to-do list, build triangles. You can do this. Build triangles. Which triangles can we build? Trace the sides. Like, here's a side they gave us, and here's an angle they gave us. That is 2 pieces of this blue triangle. 2 pieces of this blue triangle. So if I go over here and I draw that blue triangle, we have this side, we have this angle. We have 2 parts. And then I'm going to call it angle 1 and 2, but we have vertical angles. So now we have this angle matching. That would give me congruent triangle. So I can now say triangle RTP is congruent to triangle STQ, and that would be angle, side, angle. We have 2 angles and the included side. So now I got the blue triangles. I just got over half the points. All right. So again, once we have congruent triangles, this is where the difficulty ramps up. Which triangles are we trying to get? We're trying to get URQ. So I'm going to trace it. URQ. And this is a little bit easier than the other one because they're telling us which triangles to make. Earlier, we had the situation where we had to figure out which triangles. This one, they're telling us. It's URQ and USP. So keeping in mind that those are the triangles we're trying to make. Here's the green one. What do we already have? Well, they already told us these 2 sides match, right? So, US is on the green triangle. UR is on the orange triangle. Now, to be clear, the green triangle is this whole side. Does it touch UR? Yes. But UR is not a side of the green triangle. UR is a side of the orange triangle. But we do know that the right side of the green triangle, right over here, the right side of the green triangle matches the left side of the orange. So we got one match. That's all we got. So what's next on our to-do list? Where do the triangles overlap with each other? Where do green and orange overlap each other? Or do they overlap with the previous triangles? Sometimes it helps to look at the names. Let's look at these names. URQ, USP. They have one letter in common. One letter would give me an angle. Two letters would give me a side and two angles. Now, the angles aren't guaranteed, right? So an angle, like we talked about earlier, like if I said angle U, 1, 2, 3 U's, it's got to be the same angle U. Is this angle U the same one? If this was 20 degrees at the top, the orange triangle and the green triangle, would they both have a 20-degree angle? Yes. Orange and green would both have it. Angle U is the same for both of them. So I'm going to call that angle 1, and I'm going to say angle 1 is congruent to angle 1. That is a reflexive property. They both use it. So that's where they overlap with each other. How about where do they overlap with the blue? You can try to look, like trace the green. Like here's the green triangle. Here, I'll change color so we can see a little better, but trace the green triangle again. No blue. Oh, here's some blue, but while this blue side stops, my blue side keeps going, so that's not helpful. Keep going. Here's some more blue, but again, this blue side stops, whereas mine's the whole thing, so that's not helpful. Turn. Does this turn match the blue turn? Yes. Yes, this is my spot. We can tell by the name as well. It's triangle, look at the letters, USP. What is this one? RTP. They have the letter P in common. Is it the same letter P? Well, yeah, there's only one angle P in the picture. I'm going to call it angle 2, but there's only one angle P in the picture. So angle 2 is congruent, call this one 3, to angle 3. Right? P, we know that P and Q are the same size. We know that this corner and this corner are the same size. So now on the green triangle, we have the top is a match to itself. We have the bottom left. Now we're in business. Now we can say triangle URQ is congruent to triangle USP. And what is that reason? Angle, side. Angle, side. Nice work. I'm going to skip this one for now. We might do this one another day. I'm going to go to this problem. This is the same question I ask you to do on your homework. This is a really hard question. It's very high level. First thing they tell us is WS is congruent to SY. And I'm going to kind of mark it out here because there's a lot going on. This is congruent to this. We haven't dealt with this yet, but if those two sides are congruent, what is true? This orange triangle would be isosceles. Which angles would be congruent? It would be the entire angle W and the entire angle Y. It's the entire corners. All right, so those two corners, I'm going to call them corner 1 and corner 2. So I'm going to put that in my proof. I don't know if I need to use it, but it doesn't hurt to put it in my proof. And it's not technically true. I'm just going to say definition of isosceles. We're going to cheat a little bit here as well. Technically, you would have to establish that SWY is an isosceles triangle because the base angles are congruent. Then we could say this, but we're just going to skip that step. We're going to say definition of isosceles. Okay, and then they tell us WC is congruent to BY. So what triangles are they building? This one's hard to see. If I trace this side and I trace that angle, this is the triangle that I have. I know. Trace this side, trace this angle. This is its friend. We have the two triangles, the red and the black. If If I were to draw this one, I have this side and I have this angle. Do red and black have anything in common? Hopefully you can see, hey, they've got this shared side at the bottom. So I need to get that in here. I need to say WY is congruent to WY, and that's reflexive. Now I can say triangle CWY is congruent to BYW. And what do we have? We have two sides in the included angle. So we just got over half the points. That's tough. That's tough. This is definitely harder than what you have to do on the quiz, and that's just flat out a tough thing to do. Okay, this one's also hard because it's a lot. They didn't tell us what triangles to use. They said COBO. They said COBO. What's the strategy? Highlight CO and highlight BO. And here's what you're trying to do. You're trying to find two triangles. One that uses CO and one that uses BO, so that if they were congruent, we could use CPCTC to say these parts are congruent. And hopefully you saw that these two blue triangles are the only ones we can use. So what are the parts we know? We have the rights. We already have left and right congruent, but we need more. So I'm going to call it angles 3 and 4, but we have vertical angles there. So I'm going to say angle 3 is congruent to angle 4, and that's just vertical angles. And then how about the rest? Man, is this tough. Do the blue triangles overlap with each other? The answer is no. Do the blue triangles overlap with the old triangles? In other words, does blue overlap with red over here? Or does blue overlap with black over here? And the answer is yes. They overlap at CW, but we already have that, so we don't have to say anything about that. But let's look at the name. What would be the name of the blue one? The blue one would be called COW. Let's go look at the name of the one we wrote. CWY. COW and CWY. Yes, they both use CW, but we already have that. They both use W. Look at that angle W. Is it the same one? Is the red angle W the same as the blue angle W? The answer is no. The red angle W is the entire corner. The blue one is the small piece. How about angle C? Because they both use C. Do red and blue use the same angle C? And the answer is yes. I'm going to call these angles 5 and 6, but we know that this C and this B are the same size. And that is CPCTC. And now we can say our triangles are congruent. Triangle cow is congruent to triangle boy. And that's going to be, what do we have? So we got this angle at the top now. We have angle, angle, non-included side. We have angle, angle, let me mark the picture, non-included side. So can we now say CO is congruent to BO? Yes, we can. So 3 was 4, C and B, cow and boy. All right, I like it.